Hi there, this is Vahid from VRF Education channel, and it's the third session of object-oriented programming in Python. Today, I'm going to talk about constructor inside Python classes. Constructor is a special type of method inside classes in almost every programming languages. When you want to create an instance from a class, the constructor will be called automatically. And as the name implied, it's used for constructing an object or an instance of a class, and we usually initialize our object inside this method. In Python, constructor categorized under magic methods category. A magic method in Python is a method that starts with double underscore. Double underscore init play a constructor role in Python classes. In other programming languages such as C# or Java or even C++, constructor is a method with the same name as the class, and we use it mainly to initialize our object. What does it mean to initialize object? As we said in previous sessions, each object have a couple of fields inside it. Those fields are gonna describe the object. For example, if we want to create an account class and then instantiate from it, fields such as account number, the owner, opening date, opening balance are the fields that describe this account for us. And by looking at these fields, we get a total information about that account. And in Python, or even in all programming languages, fields are categorized into two levels, object level and class level. Object level fields are those that are specific to each object. If we create two different instances from a class, those two instances have different values for their fields. But class level fields are shared among all objects that instantiate from a class, and we'll talk about it in this session very soon. Another thing about constructor that I forgot to tell is that if we forget to add a constructor to a class, Python interpreter automatically add a default and empty constructor for that class implicitly. It means that all classes in Python has a constructor implicitly or explicitly. Okay, so if you forget to add it, Python interpreter do it for you. And let's go to VS Code and getting familiar with constructor in practice. So we talked about constructor role in object-oriented programming. Whenever we create an instance of a class, for example, here we create a P1 from the class point, the constructor will be called. In almost all programming languages, if we didn't define any constructor in our classes, then the interpreter or compiler of that language create a constructor, an empty constructor, as a default for us. So all classes have at least one constructor, implicitly or explicitly. Here we forgot to create, or we didn't need to create a constructor before. So Python itself created a constructor for us implicitly. Now I want to create that constructor explicitly. And in Python, constructors should be used to create some variables, object variables, not class variables. We talked about variables very soon, and you should be notice that variables inside class is somehow different from the other languages. We have two different types of variables. Variables that is in object level, it means that every object has its own memory space and has its own values for those variables, and class level variables. In other languages such as C# or Java, we call them static variables. Those are class level. It means that all objects share the content of that value together. But in Python, it's a little bit different to create this kind of variables, and we're gonna check them. If you are new to object-oriented, especially new to programming and start programming with Python, it's very normal for you. But if you migrate from other languages to Python, especially C families, it will be a little bit confusing in the beginning, but you will get to it very soon. So to create a constructor, we should define a special type method. Dunder or double underscore init is in Python is oh, what's happened? Something open. I didn't need it. This magic method, dunder init dunder, is play the role of constructor in Python classes. And as it should be act on the object level, we should assign the self parameter to it as the first parameter. So this is just a parameter. This is just a method that will be called whenever we create an instance of a class. So here I want to create just print out something, construct or an object created. Okay. Now, if I comment out this line and run the program, something P1 is not defined. Let's run it one more time. Okay. An object created. It's because I just create an instance of the point class, so the constructor automatically called, and the print just goes to the console. If I just copy this one twice and create P2 and P3 instances from the point class, and I run the program again, you can see it, constructor will be called 3 times, each for one object creation. So what if I just create another method, another variable, and assign it to already created instance of point class, for example, P3. Here, we didn't create the point class one more time for P4. We just assign it. In the assignment, constructor won't call. Okay. If I run the program one more time, you can see we have only 3 calls to the constructor. So this is just for the time that we create instance from one class, not assigning it. Another usage or the main goal of constructor is to initialize an object. For example, when we want to create a point, we want to define the x and y coordinates of that point. A point without any coordination doesn't mean to anybody or to any metric system. So I want to just pass the 2 parameter x and y to each point. For example, you are at the x1 and y equal to 2. You are 10 and 20, and this one is 5 and 6. So 5 and 6. If we want to pass the parameter to the constructor, we should just create some variables here. For example, I need one x and y here. Now, these parameters pass to the x, and this parameter pass to the y automatically, and I can set them to some object variables in the constructor. So I just comment it out, and here, because I want to assign it to a variable inside the object, I use self. Self.x equal to x, and self. On the next one, self.y equal to y. These variables is not necessarily has this name with the argument, but in this example, because we have x and y, we just use them, but it's not necessary for them to be the same name as the argument. Okay. Now, if I create another method, print, let's create another method, def display. This method, and add the self parameter to it. This method is going to display the location of the point on the screen. Okay, I just call print and format it with the text point. I have 2 variables here, self.x and self.y. Now, if I run the program and call this method, you will be see that each variable has its own x and y variable. Okay, each instance of this class. I'm sorry. Now, if I clear this one and just p1.display, p2.display, p3.display, and you can see I can access x and y inside this IntelliSense menu. Okay, x and y are available now for me to use them directly. Display. Now I run the application, and you can see this string printed out on the console with the proper values for x and y based on those that I passed to the constructor before. In the other languages, we create object variable inside the class. Okay, for example, I'll call a variable with the default value of x here and the default variable of y here, and also let's imagine we are in a 3D environment, and also z here. These are not object variables. These are equal to static variables or class variables, class level variables. It means that all the object can share this value to each other, and this is common between all objects, not separated. But these two variables that I created inside a method of the object that has the self parameter with itself, these are dedicated to the object, not to the class. So what does it mean? For example, here I'm gonna use class point, and I can work with these variables. Okay, I can work with x, y, and z because they are defined in the class level. And I change the z to the 100. Okay, now in the display method, or let me check. Let's add the z variable into the display method. Okay, I'm gonna put comma here and tell it to print z also. So z is not initialized in the constructor, but we define it at class level. All the objects share this value. For example, if I just print it out one more time, let's save it. And what's happened? Okay, let's clear the screen out, and right. You can see all the objects share the 100 value because after creating them, I just assigned the value of z to value 100 to z. What if I just cut it and paste it at the beginning of the code before creating objects and assign it to another value 200? It doesn't relate it to any object. Okay, it's class level. So I just assigned the z value I just assigned 200 to the z value to the z of the point class, not any object, not any specific object. And now, if I run the program, you can see they all share the 20 value because it's on class level, not on object level. What if I here in the constructor, without passing any argument for z, just add self.z equal to, for example, 0, and I run the application one more time, you can see this time when I said I'm just looking for the z on the current object, it says that yeah, I have it and it's directly set to 0. In the previous example, if I comment it out, let's comment it out and print it one more time. It says I'm looking for a z in this object. It said, okay, I don't have any object with I don't have any field with the name of z, so I should look in my class template. And in that class, I have already declared a parameter with the name z, so it uses it, and we just assign it to the value of 200. So this is the difference between class level and object level variables. Now let's check something else. What if I want to print it out these two variables? For example, I want to assign them to 30 and 40. To access them, we can when we use self.x, it refers to the local parameter, to the parameter that we initialized inside the constructor. What if we want to access this x, the x that is inside the point class? We have two approach. We can use the class name as we, what happens? Yeah. We can use the class name as we used it here to set the value, and we can use them again to read the value, point.x and point.y. Now if I run the application one more time, you can see here x and value equals to 30 and 40 because we just said that go and read the x and y value declared in the class, not in the object. And if we want to use, we don't know the name of the class, and we want to do some reflection things and accessing them at runtime, we can use something like this: self dot dunder class. It refers to the class that we create this object from. And now let's change it also to the self dot dunder class dot y. The result is the same. Okay, if I run it, you can see 30 and 40 for these x and y's. So if you want to some dynamic actions at runtime, you can use this approach, self.dunder class, instead of using the class name directly. And if I change the value of z, for example, here I'm gonna, or we can use p.dunder class dot z equal to, for example, 600. Run it one more time. Here we have 200 because we call it before the new assignment. And after that, these two other objects, P2 and P3, refer to the new value of the Z of the base class, okay? Point class. And one more thing. What if I, here, I'm gonna create P2.Z equal to, for example, 1000 and run the application one more time. So something strange happened. This 20 and this 60 are obvious because we're gonna use the Z of the point class that is declared directly inside the class outside of any object methods. But what about this 1000 of P2? In Python, because the nature is interpret, not the compile, when we assign a new value to a variable that does not initialize in the constructor, the variable will be declared inside the object. Okay, it's a little bit strange for the programs that have experience with the other languages, but in Python it's very common to create some variables or add variables to already created instance of a class. This can bring you some flexibility, and on the other hand, it can get you confused or making some trouble for you in future. This is just a knife that you should use it correctly to get the best use of it. So what if I let's duplicate this line? Oh, what's happened? And here, before adding the z value to the p2, it uses the z in the class level, and after declare it as the local variable for p2, in this display call we used it we used the local z, not the z in the class declaration. Let's run it. Oh, something. Okay, so you can see for p2 we have 600 at first, and after adding the z to the p2, we have 1000 as the value of the z parameter. So this is how we can create variables inside an object using constructor, or adding variables to the object after creating them, or how to use the variables inside the class, inside class levels. These are equal to static variables in the other languages, and these are equal to fields or attributes of the class in the other programming languages. In the other programming languages, if we declare variables inside the class, this is equal to the object variables. And for declaring a class level or a static variables, we should use a static name directly. In Python, it's a little bit different, and this is the whole thing about creating variables and using constructor. And also, in the other programming languages, we can have a couple of constructor. But in Python, it's a little bit tricky to have a couple of constructor, and we will talk about it after we talk about class level methods. Okay, wait until that, and we will tell you a trick to have a couple of constructor inside your class. But right now we can have only one constructor, and it's better to create the constructor inside the class to control over the object initialization of that object. Now imagine that I want to create a student class that contains the name and the grade for the Python and database and data structure of each student. So based on what we learned till now, let's comment all of this. Okay, we can create a class using class keyword. Students is the name of class. Student. Oh, I'm sorry, you get confused with the C#. Now in the constructor, first we need to create a self parameter, and after that I want a name, and then db grade, db underline grade, ds underline grade and Python underline grade. So self dot name equal to name, self dot db equal to db grade, self dot ds equal to ds grade, and self dot python equal to python grade. And I want to create another method, def display self. Here I want to print it each student with his or her number. Print student name and the numbers. Create some literals. Okay, here we should use self.name, self.db, self.ds, and self.python. This is just a simple method that I want to display the information about the current student. Now I'm gonna create a new student called Vahid equal to student. He is a student and his name is Vahid also. Again, the number for DB is 20, 10, and 20. And I create another one, Sarah. The name equal to Sarah, and value is 12, 14, and 19. So let's just use Vahid.display and Sarah.display. Okay. Check the output. You can see the name is Vahid, Sarah, and variables also assigned to the appropriate ones, DB, DS, and Python. So one more thing about the constructor, we can control over the object initialization. For example, I want to have all the names in capital. So here I can just use upper method of the string to cast the names to the capital. Upper. And now if I run the application one more time, you can see it doesn't matter what we entered or what we pass to the constructor in lowercase or combination of lower and uppercase. It will be casted to uppercase totally and displayed out on the screen. So we can control or change the object initialization based on our logic or based on our preferences. And also if we introduce you the property mechanism inside the Python, we can control over the object object assignment or object field assignment in future. So what does it mean? What if I here change the Vahid.name equal to Vahid again? So although I change it to uppercase here, but after the creating object, I change it one more time. And here, because I assigned it directly, so it get back to lowercase. So if I run one more time, you can see Vahid is lowercase again. This is a temporary location to control over the object, but if we get familiar to the property mechanism, we can control over object initialization and assignment in future in the runtime and control the way that we want the data put inside the field variables. So this is all about the constructor and fields, and we will talk about them in more details in next sessions also. And we're going to check other aspects of object-oriented programming in Python in the next session. I hope you enjoyed the content, and I will be glad to share your ideas with me in the comment section. Thank you.